Hook scientists have discovered that chocolate and blue cheese share more flavor compounds than chocolate and vanilla do. Let that sink in for a moment. Two foods that seem completely opposite, one sweet, one pungent, are actually more chemically similar than two things we have been pairing together for centuries. This single discovery shattered everything the culinary world thought it knew about why certain foods taste good together, and it opened a door to combinations nobody had ever dared to try before. Tease in the next 10 minutes, you are going to learn exactly how flavor pairing actually works at a molecular level, why some of the greatest chefs on earth are now using chemistry databases instead of cookbooks, and how a handful of completely unexpected food combinations are producing some of the most mind-blowing dishes ever tasted. We will also get to the one principle hiding underneath all of this, a counterintuitive truth about flavor that most cooking shows will never tell you, because it contradicts the most basic advice home cooks have been following their entire lives. Background: for most of human history, flavor pairing was purely instinctive. Ancient cooks learned through trial and error, passing down combinations through generations without ever understanding why they worked. Salt and meat. Lemon and fish. Tomato and basil. These pairings became cultural touchstones, embedded so deeply into culinary tradition that questioning them felt almost disrespectful. But nobody was asking the real question underneath all of it: what is actually happening inside these ingredients that makes them work together? The first serious scientific attempt to answer that question came in the 1990s, when food scientists began cataloging the volatile aroma compounds found in different ingredients. These are the chemical molecules that evaporate from food and reach your nose, and they are responsible for the vast majority of what we actually experience as flavor. Taste, strictly speaking, only gives you 5 signals: sweet, salty, sour, bitter, and umami. Everything else, the richness, the complexity, the memory it triggers, that is all aroma. And aroma is all chemistry. By the early 2000s, researchers had built the first comprehensive databases mapping these aroma compounds across hundreds of ingredients. What they found was astonishing. Certain foods that seemed completely unrelated shared large clusters of identical volatile molecules. And when chefs started testing these pairings in real kitchens, they discovered something remarkable: ingredients that share key aroma compounds tend to taste harmonious together, even when they seem to have no business being on the same plate. Main content: this is the foundation of what is now called flavor pairing theory, and it has been formally developed through work at institutions like the Flavor Network Research Project, which analyzed over 56,000 recipes and identified patterns in which ingredients appear together across global cuisines. The data revealed that Western cuisines, particularly North American and European cooking, strongly favor ingredient combinations that share many overlapping flavor compounds. East Asian cuisines, interestingly, show the opposite tendency. They tend to pair ingredients with very few shared compounds, relying on contrast rather than harmony. Both approaches produce extraordinary food, which tells us that flavor pairing theory is not a rulebook. It is a map. So what does this look like in practice? Take strawberries and black pepper. On the surface, that seems strange. But both contain a compound called uraniol, which contributes sweetness and a slightly caramelized quality. Add freshly cracked pepper to ripe strawberries and something magical happens: the pepper amplifies the fruitiness of the strawberry rather than overpowering it. This is now a classic fine dining combination, and it works entirely because of shared chemistry. Parmesan cheese and coffee is another one. Both are extremely rich in glutamates and share a number of roasted, nutty aroma compounds produced through similar aging and roasting processes. Chefs at restaurants like the Fat Duck in England, Heston Blumenthal's legendary laboratory kitchen, have used these insights to create dishes that seem bizarre on paper but make complete sensory sense when you actually eat them. Blumenthal was one of the earliest adopters of flavor pairing science, famously pairing white chocolate with caviar after discovering they share trimethylamine and other overlapping compounds. The combination became a signature dish. But here is what nobody talks about when they discuss flavor pairing science. The theory only explains part of what makes food taste good. It accounts for harmony, for the seamless blending of complementary molecules. What it does not fully account for is tension, contrast, and the psychological dimension of eating. And those elements are just as powerful. Deep dive: there is a second school of thought in flavor science that actually challenges the pairing hypothesis directly. Researchers analyzing the data from East Asian cuisines found that these food traditions, built over thousands of years and producing some of the most complex and beloved flavor experiences in the world, frequently pair ingredients that share almost no volatile compounds. Thai cuisine combines fish sauce, lime, chili, and coconut. Japanese cuisine pairs miso with dashi and fresh vegetables. These combinations work not because of chemical similarity, but because of contrast, balance, and what food scientists call flavor bridging. Flavor bridging is the idea that you do not always need two ingredients to share compounds with each other, you need a third element that connects them. A vinaigrette works because oil and vinegar do not naturally want to combine, but mustard contains emulsifying agents that bridge them together, creating something more unified than either ingredient could produce alone. This principle scales up to entire dishes. A sauce built on butter, white wine, and shallots works not because all three share flavor compounds, but because each one contributes something that the next element needs to make sense of. The most advanced research in this field is now happening at the intersection of chemistry, neuroscience, and psychology. Scientists at institutions like Wageningen University in the Netherlands have been studying how context, expectation, and sensory memory shape flavor perception. In controlled studies, the same food described with different words produced genuinely different taste experiences in participants, not just different opinions, but measurably different neural responses. The plate, the lighting, the music playing in a restaurant, all of these elements change how your brain processes flavor. A strawberry served in a white bowl tastes sweeter than the same strawberry served in a black bowl. This has been replicated in peer-reviewed research multiple times. What this means for flavor pairing is profound. Chemistry gives you the ingredients for great flavor combinations, but perception gives you the performance. You can engineer the perfect molecular harmony between two ingredients and still produce a disappointing dish if the texture is wrong, if the temperature is unexpected, if the visual presentation breaks the eater's mental model of what the food should be. The greatest chefs working at the frontier of gastronomy understand that they are not just cooking for the palate. They are cooking for the entire nervous system. Analysis. So what does all of this mean for the home cook? The practical implications are actually more accessible than they might seem. Start by understanding that aroma is flavor. Anything that makes food smell better will almost always make it taste better. This is why toasting spices, browning butter, and caramelizing onions work so consistently. These are all chemical processes that generate new volatile aroma compounds, expanding the flavor profile of relatively simple ingredients. Second, do not be afraid of counterintuitive pairings. The next time a recipe seems strange to you, ask what the ingredients might have in common at a deeper level. Honey and goat cheese work because both carry floral compounds. Banana and cardamom share eugenol. Lamb and coffee both carry powerful, slightly bitter, deeply savory notes that reinforce each other under long cooking. These pairings are not accidents or tricks. They are chemistry in action. Third, think about contrast as a tool, not a mistake. The reason a salted caramel tastes better than plain caramel is not just because salt suppresses bitterness. It is because the contrast between the salt and the sweetness makes your brain pay more attention, increasing sensory engagement. Contrast creates interest. The most memorable flavor experiences almost always involve a moment of tension alongside the harmony. Conclusion: flavor is not random. It is not purely cultural. Before you go, if you learned something valuable today, hit that like button right now. Subscribe to Flavor Vault for a brand new video every single day. We will see you in the next one.